G'day everybody, just a quick tutorial, about 14 minutes, on how to create some custom code to add functionality to value ops. G'day everybody, so for this quick tutorial we're just going to look at the value operator. The expression library does not have a way to generate random numbers. What if we wanted to do something where we create a random number and then use that to control our particles? So I've set up a very simple max file, which is mainly for the purpose of looking at the code, how we did this, reusing that code, explaining the code, and anybody that watches this tutorial should be able to create some sort of variation. So we're using a random number to generate random colors. Now, for the purposes of this tutorial, just forget that in the material ID there is a way to assign random colors, but we can totally control this in the value op and code. And we're also controlling the size. So if we go in and look at this simple flow, we can see here that an expression operator is controlling the material ID. Right, and it's coming from a custom float, and we can also see here that a custom float is controlling the scale, and if you look carefully you can actually see that I've just put a divide by symbol in two, so essentially whatever is being returned in this custom float I'm dividing it by 2, and hence tyFlow is pretty smart. It actually even shows that I'm reducing it to 50%. But regardless, these two values that we saw in our flow are being controlled from random numbers that are not possible in this expression library, and we're just going to go through how we use some C script that I'm going to explain all of this. You'll be able to do this if you want to, right? And you can use it for anything: speed, scale, rotation, whatever, right? We're using simple visual adjustments so that we can visually see them in the flow, and we're doing it on simple flows because the purpose is to understand the process of what is happening here. So having said all that, just to summarize quickly here, we're using some custom code that can generate random numbers. We're putting those random numbers into some custom floats. We're retrieving those custom float values to affect our particles. Now let's go through all of that, and this should be a quickie, but a lot of cool information here. The material. I've got a multi-sub object. It's got 8 objects, but I'm only using 6 of them, first 6 materials, and you can see I just got some fairly standard colors, some kind of prime-like colors, and that's been applied to the tyFlow object. But the main point is here right now the valid values is 1 to 6 for material IDs, right? And we can see here that the range of colors is being applied to our random generated particles with random sizes and random colors. Now we're returning integers in this whole thing, and don't worry, I'm going to explain this in depth. And that means whole numbers. So for most part, if we even looked at the size of these, the scaling of all these would be some sort of whole number, 1, 2, 4, etc. Whatever we're returning, it wouldn't be 1.25, 1.3, etc. Same as with the colors. So when we look at this, we've got 2 custom floats, one to hold, and the reason I have 2 is I wanted to scale differently to what I wanted to color. I could have just had one custom float that would have done both the scaling and the coloring, but I just wanted to show the diversity of the code, so it may be more useful for something and more teachable moment kind of thing. So I've set up an iRandom number, and I've set up an iRandom number size. So one is for the color and one is for the size. Then we come in here, and the importance of this order, there is importance to this order before, of course. First we want to create the custom floats, and we're using custom properties to do that. Then we want to create the random numbers which we're going to put into these custom float values. Then we're going to retrieve those custom values to apply to our material ID and scale through these expression operator value ops, right? So expressions. So that's kind of the order. But when we look at this code here and we open this, and I've kind of structured it nicely. So up here I've made a little place outside of the simulation step to store my minimum and maximums for both color and size. That way if I want to alter it easily I can. For example, if I only want to use colors 2 to 5. Now this is the max value, so it actually returns one less. That's the way the random function works. So in this instance I'm returning a value between 2 and 4 with these settings, right? And then if I go file evaluate, you'll see that everything changed here. Now more or less just limited to 4 colors, right? 2, 3 and 4, actually only 3 colors. And so now we can go back to 1 and 6, for example. 1 and 7 if we want the full range, right? And then file evaluate. So up here I've just structured this nicely to make these settings easily accessible. It's easier than going in here and finding those here and adjusting them and then maybe messing up the code. So the whole purposes of this up here is just to make it really easy and almost foolproof to adjust. If I want to change my size, this will end up returning a value between 2 and 18, for example, right? And evaluate, and we can see. So that's makes it really nice and easy to make adjustments to our code. Alright, so now that we've kind of seen what's going on, right, and you can call, right now we're only calling it to return integers, and we're setting the minimum maximum. There's different ways this random number generator can be used. You can also return decimal values or floats, right? So let's go over the information part of this. And of course, this is a very simple flow for the process of showing this stuff. This can be made way more complex and used in many creative ways. So I'm going to show you 4 document-like pages that's going to explain everything about this flow, with the goal that you should be able to do this by yourself and do variations of it to do whatever you want with, say, for example, randomly generated numbers. So with these 4 pages, you can pause them on the screen because there's a lot of explanation here, but I've already kind of quickly went over it. We're birthing 100 particles over 100 frames, which basically more or less equals 1 particle per frame. Now it doesn't really matter how many particles we birth, except that there's 2 kind of variations of this code, where one you can have the color change per frame, or you can have the color change per particle, which just adds an interesting variation to the randomness, right? Like if you were birthing 5 colors per frame, you could technically birth 5 the same colors and only have it change every frame, or you could make sure every particle has a different random number value assigned to it. We're just giving it the shape. In this case we're doing cubes and we're spitting them out at random speed. We're setting up 2 custom floats called these names, and they are to store the random generated numbers that we will use over here to assign color and scale. We're writing some script that we're putting in a script file, and that's using a standard C+ random number generator function, and we're also going to explain that. That is going to generate those random numbers to put into these custom floats that we will then use to control our particles. And the sequence is important, but again, just read the screen, but that's the general gist of what is going on. We assign a random material ID from our custom float, and we assign random scaling from our custom float. We divide it by 2 because I just wanted to show you could do that. And then here's the 2 variations, right? And it's about the placement of these 2 lines of code, right? Down here you can see it's inside this for loop, and this for loop is what actually steps through every particle and then assigns the material. So if you apply the generation of the random number outside of that for loop, then you will get groupings of the same color or same scaled or same whatever on each frame time step. If you put these two lines inside this for loop, then you'll ensure that every particle gets a random whatever it is you've assigned to it. So that's the main difference and two different ways to use this code. Then we go here to explain the code, and this is a really great in-depth explanation of all the lines of code that are in this script operator, and you can use that as a learning tool if you want, or you can just use it to copy and hack and edit my code at your will. We're using a standard C random number function over here, and there you can see the different options. So this is the way that you generate a random number. We've structured it more nicely over here. Next, we'll just return a positive integer with no low or high max, right? Next integer will return a positive number less than whatever is specified in here. So for example, if we said next and we put 6 in here, it will return a value between 1 and 5 type of thing, all right? And then you can actually set the minimum maximum, which is what we're doing here, right? We've just structured it nicer, but we're using this part of the next, and that's what's going to return a value between a minimum and a maximum. And here's how you would create a random decimal number. Now it returns a random value between 0.0 to 1.0. So if you wanted a bigger range or whatever, you would have to multiply it. And of course, you would also have to change the declaration. You can see here we're saying int, which is integer, right? So it's going, when we return this function, it's expecting it to be an integer variable that we're going to store. If you want doubles, then you're going to have to do doubles, and then you're going to have to do some typecasting. But let's keep it simple, and let's keep this working explanation, and pause the screen, and you will get all the information about how this code is structured and what it does. And here we just kind of go over the custom creation of these random numbers, right? And you can see this is a breakdown of the flow with the most important information. So really from this screen you could recreate this flow totally the way I've done. So if you were to pause the screen, all the information you need to recreate this in your Macs and your tyFlow would be right here. Now there's also a variation here where on event entries, I'm doing everything more or less on event entry because I only want to assign the materials once per particle birth. I don't want the particles flickering and flashing different colors and being psychedelic, right? So again, there is everything you need to know to more or less use a custom C+ function to create random numbers. That's not possible with the standard expression toolkit, and you really don't need to know a lot of coding, and this is the process of how you would do that. And it's kind of could really be useful as a way to generate some random kind of pattern, random whatever things you want within tyFlow. I hope you find something in there useful. Have a good one, everybody.